Good day to everybody and welcome to this webinar. Today, our partner Fingerprint, we talk about the all-new biometric sensor family, the FPC AllKey. I am Davide Osto, Vertical Segment Manager for Sensors working in Future Electronics. A few quick announcements before we begin. The presentation, along with the webinar recording, will be available to all participants at the end of the event and will be shared via email. If you have any questions, please write them in the dedicated chat box. A Q&A session is scheduled at the end. Now, I'll hand it over to today's presenters, Matthias.
Thank you, Davide. So I'm Matthias Kalén. I'm from Fingerprints, and I'm the General Product Manager here for our Access product area. And I'm going to present our new product launch, FPC AllKey, that enables secure biometric solutions for products in the Access segment, as we call it. So I will start by going through a bit on why you should use biometrics in general, and then present a bit about the company Fingerprints or Fingerprint Cards that we're listed as, before I start exploring our new product FPC AllKey and all the benefits and applications that is targeting, before the question and answer section in the end. So why biometrics? Globally, we see an increase in security breaches, and with that increase in security breaches comes a cost. So for physical security breaches, which only is 10% of all recorded breaches, the cost can go up to $4.2 million. Almost half of those breaches are related to customer personal identity information like names, phone numbers, ID numbers, and so on. And that's not so good because those are the breaches that are take the longest time to identify and contain. All these numbers that we're showing is from IBM, which does a yearly survey of security breaches and the cost of that. And the soaring cost of the fraud and data losses is driving a lot of markets to stronger security factors. And here's where biometrics comes in, and fingerprints is a biometric modality, and it is unique to the individual, and unlike passwords or pins, it cannot be transferred and shared. So it's much harder to forge. That said, we have the security part, which is enhanced by biometrics, since it's individual, making it much harder to replicate than traditional pins or passwords. There's a reduced risk for data breaches with that. You need to be physically present, which adds an additional security layer, more or less. The non-transferability, you can't share your biometrics. That reduces the risk of frauds and unauthorized access by sharing credentials or stealing them. And you also get an improved accountability. You can have a clear record of who actually entered a premise or a facility, or a digital domain, because you need to be physically present. Next step, additionally to security, there's the convenience factor also, which we play a lot on. You don't need to remember complex passwords. You don't need to remember pins. You can just touch the fingerprint sensor and you're allowed, but with maintained high security. And the convenience factor, as you can imagine, should save you a lot of time. This is numbers from the smartphone world, where biometrics has been used for quite some time now. Replacing pins and passwords saves you a lot of time to do better things than entering passwords and pins. And that can be valid for any product, not only mobile phones or PCs. where you actually need to enter something. Then fingerprints or fingerprint cards, as we're listed on the Stockholm Exchange as, was founded in 1997. We've been in biometrics since then. We've shipped over 1.5 billion sensors, reaching 2 billion sensors now. And our main market has been in PC applications and mobile phones. With all the largest, not all, but most of the largest customers or brands within those domains. That is where our most volume has been driven historically. We're looking now into, we're also one of the largest, we're the largest fingerprint sensor supplier to door locks or door manufacturers. We do have an iris recognition library as well that we provide primarily for automotive sector now. And we have a future in biometric payment cards, which is starting and we're trying to push that out. And there's a lot of pilots ongoing and bank launches on the biometric payment card side, where we have a large upside in volumes. Potentially. We're a Swedish-based company. We have all our design and development is done in Sweden. And that's something that we're proud of. That's our heritage. Now I mentioned access maybe a bit. That's more or less everything that it is not. When I talk about access product area, it's more or less everything that is not covered by mobile phones, PCs, or payment cards. So any device that actually where we integrate a fingerprint sensor or a biometric modality. We see this launch with the FPC AllKey as enabling a new age in biometrics with fingerprint sensors. So it's our first complete on-chip fingerprint biometric system, complete system for the access market. Any product that needs security or personalization can be a good fit for the FPC AllKey, and this enables a straightforward manner to implement biometrics in any such product. Yes, I forgot. We have a short. Now I've set the scene with the biometrics and the company, and we'll run a short poll to see where the audience is in their biometric journey. And it would be great if you could help me out answering. Where are you in your journey of adding biometrics to your products? So that's the question, and the answers are no experience, considering it from my product, have looked at it before but not using currently, or fourthly, the already using it in my products. And I'm happy to see that we have quite a few people with no experience in biometrics. So we're onboarding people to the wonderful world of biometrics now, but it's a fair mix. So thanks all. For that, and I'll move on. So to set the scene a bit before I jump into the product specification and description, what do we mean when we talk about biometrics from fingerprints perspective? So in any product that integrates biometrics, which is kind of a host device. It can be a door lock, smart card, something of a pin pad, or the device that integrates it. There's a host device, and there's a software that needs to run for the biometric part. So it's a biometric embedded software that handles the sensor communication, the fingerprint sensor communication, the biometric processing of that matching. We create templates from the fingerprint image which we store and manage persistently over time, and there needs to be a host interface to the application MCU or host device, host MCU or the application software. There needs to be memory where we store the templates. There needs to be a microcontroller that runs the software and also interacts with the physical interface of the sensor. And you need the fingerprint sensor as well. So all these parts is part of a biometric solution. And during a normal operation of normal usage of a fingerprint sensor, you touch the sensor and the finger is captured into an image that is then from that image we then extract features into binary format, more or less, which we use for matching towards an enrolled template. We need to store the templates persistently to not need to re-enter every time you use it, and we need to communicate the result of the matching. All this has previously or has until now in the access space mostly been done by discrete components, which has a high flexibility, and this is where we spend most of our time until now, where you have separate components for all these steps, like a sensor, microcontroller, and a host device, and memory and software, of course. What the FPC AllKey does is combining all these components into one very minimal, complete biometric system for fingerprints. So there's onboard biometric processing. The sensor is integrated. All the sensor register handlings and so on is handled within the biometric system component, or it's a system in package, which is AllKey. That makes it a lot easier to integrate for the end device, which makes the time to market very much faster. Is the intention with the product. The biometric performance is still, or even better, since we've taken all our measures to enhance that as much as possible within the biometric system. And we have selected components for maintaining the highest security and keeping the enhanced user experience for highest convenience. The idea is to have as little impact on the host integration as possible also with this kind of system. So it's called the FPC AllKey, I think you mentioned, and we consider it a biometric system instead of a biometric sensor only. It introduces a much simpler approach to introducing biometrics in general in access systems, and it is our first on-chip biometric system. It's a system in package, so it's a very thin thing. I have it here. It's it's like a nail, more or less. It uses our latest technology, which has been kind of optimized over time in the mobile space and in the PC space and in the payment space, and we've learned all these technologies to also do packaging in a very minimal way, and being robust on the sensor technology is something that have worked with now since '97, more or less. This is the intention with the full complete biometric system is to also allow for distribution channels like Future to sell this in to anyone, and not only in the larger volumes where these kind of systems has previously been more available. And that this design minimizes the integration effort. It has the best in class biometric performance. By minimizing the integration effort, we minimize the time to market, and we have an ultra low power consumption because we've used as low power components as possible. targeted applications can be crypto wallets, access control systems like locks or doors, passkey devices, USB or other form factors for online authentication, or time and attendance, and more. These are just ideas on where you can use it, but it's possible to use anywhere you need to authenticate, I would say, or personalize. So from a functional perspective, the SIP, the device, is preloaded with software, and it provides a very simple control API towards the host MCU. We provide example code for the integration of this control API, so it should be straightforward. The interface, we have two variants. I haven't come to that yet, but we have two variants of it. It's the FPC AllKey and the FPC AllKey Pro. The Pro is more for authentication purposes and high security needs, because we add a security layer there, so the interface between the host and the AllKey is able to encrypt using pre-shared keys, enhancing the security even further. In normal operation, we just provide a positive or negative result from the verification process, from the matching to the host when somebody touches the sensor. Otherwise, we're at sleep. So we wake up on touch. We wake up and just provide the response, positive or negative, on matching. And this is the thing I've been talking about, the next generation biometric system. It's the FPC AllKey. We call it a bit of a family because it's two products at this point. We have the FPC AllKey and we have the FPC AllKey Pro, as I mentioned. The AllKey is thought more as when you need to add convenience, identification, personalization, where the Pro version is more for authentication and high security needs, where you need some tampering resistance. We also add navigation as one of our new features here. They are made of, we're including state-of-the-art fingerprint sensor technology, as I mentioned. It's a compact system in package, so no other components neither. It's an on-chip biometric processing, and all the template management is done on the on-chip as well. So nothing needs to leave the device. We include anti-spoofing algorithms on the Pro version, which are certified both in payment ecosystem and FIDO systems, and a bunch of different certification authorities. It comes as the AllKey as such is an package LGA component with a thin surface for surface with a thin coating for surface mounting, and we have a modular flex version as well. I'll come to that a bit later. So on the technical side, for the FPC AllKey, or 2532, which is the part number or the product code, as I mentioned several times now, it's a complete biometric system. It embeds a biometric processor, which is an application process, but running all the biometric matching and capture from the sensor, extract of the features, matching the templates, and also handling all the templates by managing the storage and so on. We have best-in-class biometric performance, below 2% FRR at 1/100K FAR. FRR is false reject rate, whilst FAR is false accept rate. So you set the false acceptance rate and you come to a balance to when you actually reject people that should be accepted as well. And these are good numbers, very good numbers, and I'm proud to say that we have good biometric performance. For the FPC AllKey standard version, there's support for 30 enrolled fingers or templates. All the templates are encrypted on the chip. The sensor resolution is 508 dpi, which is our sensor pixel design, which we use in all our sensors, optimized over a long time. We're adding navigation, so you can swipe up, down, up, down, left, right, long press, short press. It's a very thin package. It's 11 millimeters in diameter and 0.8 millimeters thick. It has an LGA pin backend for the surface mounting. There's no other external components needed to run it. It comes on a module on flex design as well for complete for convenient product integration. All the standard versions have a black coating, matte. It's a very durable coating. It's protecting up to 10 million finger placements. And on the module side, we do classify this for IP67 as well. So we support IP67 integrations on the product level with the FPC AllKey. The FPC AllKey 2532 has SPI or UART as the host interface, and it's configured by hardware, or that's 2 pins that you configure high or low in a set combination. We can provide a GPIO support by 3 GPIOs. So by command to the device, we can also control an LED, for example, if the LED is placed on where closer to the sensor and the host is a bit off, and you don't want to have multiple lines, for example. Ultra low power consumption. It's operated by 3.3 volts. We have current consumption during matching of 20 milliamps, and during the wait for finger, which is when we go down to sleep, we're at 15 microamps. When you're navigating, we're at 21 microamps. And this is just a small calculation. If you have a one-day operation, for example, for a door lock, you might have 25 touches per day. You end up in a 1.6 milliwatt hour consumption. We have really good responsiveness in our mind. So less than 500 milliseconds at 10 fingers. It scales a bit with how many fingers you store inside the component. That's the FPC AllKey. Then I'll jump onto the FPC AllKey Pro version, which has where we're adding it's adding another level of security. So the critical code is executed with elevated privileges within the SIP. We add the host interface, secure interface using pre-shared keys. If this is something that is important for your application, we're also adding the anti-spoofing mechanisms, a separate classifier for judging spoofs or not, with good performance or state-of-the-art performance, I would say. It has extended template management. What I mean by that is we're adding 15 fingers, so we have support for 4 to 5 enrolled fingers in this one. It also adds a possibility for template import and export, so that you can actually use multiple devices and share the templates between these ones in a highly secure manner, because they are encrypted from the sensor, and can be loaded back to the sensor or loaded to another one. We're adding two host interfaces to the Pro version, I2C and USB as well. So the Pro version is targeting more high security needs, authentication, protection from tampering, whilst the standard version might be more for convenience and identification, personalization, and such. That's the thought of the two variants, at least. So here's a brief system overview. Everything is in a package. You have four in the Pro version, or in the standard version, you have different interfaces, but there's SPI, UART, I2C, USB, as I mentioned. There's a host wake up interrupt, GPIOs for LED, interface selection, reset, and then you have the ground and voltage supply. All the components within the SIP is the biometric embedded platform. Is our biometric embedded platform, or I think we call it module platform actually, but it has a control API. We have the secure protocol. There's a matcher application. We're adding the navigation part. This is our new feature. We have and we have a capture application that works with the sensor driver that interacts with the fingerprint sensor directly, sets up all the registers and optimize the image capture every time. There's template management within the SIP. There's a flash memory within that stores the templates encrypted, and everything runs on a Cortex M33 within the SIP. So there's everything this within the small form factor of the SIP LGA. And then, as I mentioned, we're introducing navigation or move touch, which is the feature that we have had previously in the mobile phones and PCs, but we have been able to optimize that and come to a really good solution that works with low performance processors. So it adds two-dimensional navigation with your finger. You can swipe left, right, up, down. You can tap, short tap or long tap, differentiate that. And you don't need any high-performance processor. This is more of a game changer for navigation from our perspective, and this adds a new feature to our offering. You don't really only need it for you don't really need only to use it for authentication and identify, but you can also use it as a human-machine interface for user input. Other features, I mentioned the move touch, but we also have the Evo touch, which is something that learns every time. Over every touch, you actually you improve the template. So to the season variations you have on your finger, or you might cut yourself and so on, but we will handle that over time. There's this one touch thing, that is the sleep mode. So when it's not used, it goes down to sleep mode and wakes up only when you touch it. So you can have a very low power consumption. 360 touch. So there's no orientation dependency on the fingerprint when you touch the sensor. So you can have it a full rotation and still match towards a roll template that was done in one other direction. To start with using the AllKey, we have a development kit. I have one here. It comes with a pre-mounted SIP LGA with a bezel, where the software is preloaded on a finger wing board format, which is attached then to a Arduino shield. So you can easily attach it to any development board that has the Arduino headers. We do have a flex module breakout as well. That's an optional part if you're wanting to use these flex things for development. That's possible as well for creating a nice. I hope my telling you about the development kit. It has a preloaded software. We provide documentation, full technical data sheets, and integration guidelines. There's C code examples, as I mentioned before, for the host control API, and the initial out-of-box. At this point, we're working on more. We have support fully for the STM32U585 Nucleo board, but any header, any Arduino header shield equipped reference board, or you don't need that either. You should quite easily be able to implement a hardware abstraction layer from the reference example code that we provide. These are the different variants we have for the AllKey. So we have an LGA, which is more or less nail size packaged with something like that on the backside for the surface mounting. Then we provide a module on flex version with a bezel around it as well. So both these are black matte coating. You have the height and dimension. I mentioned 0.8 for the LGA, 11 millimeters diameters. For the module, that's 42 millimeters in length, the flex cable. The bezel is something that you don't need a bezel for integrating into a product, but if you're targeting for IP67 classification, we suggest using a bezel to make sure the sealing around the product while keeping an ESD path. That's the reason. The module has a 12-pin SIF connector as well. Those are the modules, and as you can see, everything is in this in a SIP LGA. So there's a stack-up design with multi-die. It's a multi-die design. Adding to that, we are able to do customizations. So it's prepared for doing different form factors. You can, on request, add different coating colors. We can have different bezels as well, but these are customization products, and the standard offering is the black one, round with 11 millimeters, as an LGA or a module, as the standard version or as the pro version. Since there's an application MCU within it, we see a potential to add other applications, reducing the total boom cost in the system. So this is something that we're exploring, but it's a bit further down. You can preload software on the SIP for a standalone version as well. And we have a lot more, as you saw the backend LGA pattern, we have more GPIOs prepared for future applications. I have tried to do a pre-recording of using it. So I'm sorry for the quality, it's a bit bad, but I think you can see that it works. So, well, the first one identifies, it turns green on the top level, then the next finger is not unlocking, and then I'm rolling my thumb here for being able to then, after A successful enrollment, identify also my thumb. Yes, so the second line turns green. And then I try again with the first one and it turns green on the first line. So that's a successful enrollment authentication. And here my colleague is showing the navigation feature. So we implemented a fun little Tetris game. And he has the sensor on the dev board on his development socket and is just swiping up and down, playing Tetris with it. So it shows that you can actually use it for more than only the authentication or identification part. Navigation works quite well. And as a summary, then why biometrics? Yeah, passwords and pins, they are not secure and cumbersome. That's a statement. Less secure and cumbersome than biometrics, maybe. There's high financial implications on from breaches, and you also have a worse user experience than just something easy touching. Why choose AllKey? It's convenient and secure. So, and primarily, it's very easy to integrate as a standalone biometric system. And it's available now. All right. So let's jump into the Q&A.
Yes, we have a few questions indeed. I believe that some of the question has been already addressed, but anyway, is there a available off-the-shelf starter kit or dev kit to evaluate it? I believe that you just answered this one. So yes, we are keeping stock of that. Then, what is the expected recognition rate? I'm asking because we all know good and bad fingerprint sensor, for example, a mobile phone.
Yeah. So the expected recognition rate in terms of biometric performance is, I mean, if we set it at that it's 1/100K, that's a general, I mean, that's a larger population. And then at that point, you get a 2% rejection rate. So that's the balance that we have set it at. That said, of course, there will be some individual that might not have a fingerprint, for example. Then that will not work. But if the question is on a general, full global population, I cannot really respond to that off my head. I'll need to check if I have data to provide that.
Okay, we can maybe address the question more in depth offline. So what about a rough of the idea of pricing? So this is something that we should deliver as future electronics, but you can anyway maybe give an indication like less than.
Yeah, it's highly dependent on volume because we're a volume component provider, of course. I have my colleague Gonzalo on the call. Maybe you want to mention on this one?
Yeah. Hi everyone. Hi everyone. Gonzalo de Gisbert. Yeah. So as Matthias says, the pricing is very much volume dependent, but you're not very high volumes depending on the package. You know, we're talking sub $10 sort of thing in terms of what you can achieve. But of course, depends on the volume, the package, over what period. But hopefully that gives you a sense.
Thanks, Gonzalo. So the next one is for short or long tap recognition. You do not check the fingerprint match, only the tap, right?
Yeah. So when you're in navigation mode, you have to set it in navigation mode or identification mode by controlled API. So either you're in navigation or you're in identification. And when you're in navigation, the tap is not authenticating at this point.
Okay. Okay. Another one related to the condition when the finger is wet. What about the fingerprint sensor functionality?
Yeah, in general, if it's totally wet, that will be tricky. You might need to just wipe your finger off to have the best performance. But we are already integrated in door locks outside, and it works. We do often kind of guide that a bit of covering the sensor is always good, of course, but in general it works, but not in the worst cases. We need to be a bit cautious on water. It is a tricky thing with capacitive sensing.
Okay, thanks. And then when it comes to storage of biometric data in industrial application, are there any data protection issues or problems with the Cyber Resilience Act?
With this, okay, so it's the specific Cyber Resilience Act for industrial applications. I think I need to come back on the explicits on that one because I don't know that standard explicitly. But in general, we don't. The biometric data as such never leaves the device. Um, if you don't, it shouldn't leave the device. It's on chip, and the templates is also on a binary kind of proprietary format, of course, but it's not the biometric fingerprint that is stored either. So that gets it further and more secure.
Okay, there's another one which is two questions in one. Is the sensor capacitive?
Yes, sorry. Yes, it's a capacitive sensor.
And why would you want 45 fingers registered on the same device?
Uh, it's up to the customer really, but in a lot of door lock applications, for example, you might be multi persons entering and exiting the building, and then 45 is requested at some times. This is based on customer request, so it's really depending on application, I would say, but
Okay,
essentially
that's
multiple people entering a building or an office.
yeah. Okay, thanks. There's another one related to the use cases. So you show basically like door locks, one of the main application for such devices. But why should a modern alarm, like a burglar alarm or a smart home system, domotic system, should include a fingerprint sensor on top of it?
I mean, I think that's a pretty good implementation because you usually have a pin code or a quite long pin code that you need to turn off the system with or enter it to turn it on. It can be tricky to remember, and it's also not that easy for children, for example, to use it or other ones. And you can just enroll the fingerprint and then you turn it on or turn it off by your, touching the sensor, and that's secure still. So I think that's a good use case, and
Okay, and
we have such applications actually on the field as well.
yeah, you just need your finger. You don't need any smartphone. You don't need any pin code tag, whatever. So
No.
it's just your finger, and then you can disarm and alarm the burglar alarm system, for instance, or maybe
Yes.
just attach the domotic system and get, I mean, the overall setup according to your needs, to
Yes.
the user experience. Okay.
So that's also a good thing. You can personalize smart homes or whatever you wish to do with the touch of your fingers because it's you.
Okay, thanks. And the second one is which microcontrollers are supported currently?
So as I mentioned, out of the box at this point, we're supporting the STM32U5 series nuclear board, but the code we provide is adaptable for any hardware abstraction layer. So it's a very small thing. Well, a small thing. It's a small integration to provide to do a hardware abstraction layer adaptation based on the reference code that we provide. We will work on more reference code, but of course we cannot have everything. So we try to have the reference code as easy to adjust for the customer needs as possible.
Okay, so a lot of questions. Another one which is quite technical. So, what is the size of the fingerprint that you are eventually transmit from one 2534 to another one?
That's a good. So we're transferring templates, and each template is around 20 kilobytes. If that answers the question. If it's actually the size of the fingerprint, that's another thing. But the template size is around 20K.
Yeah, I believe that it was more related to the template size. Another one is we will have the link for the recorded session. Yes, you will get it. So I can answer that. Then, how do you handle the general data protection regulation? Is the storage of biometric data excluded?
So we say at this point, we don't store the biometric data, but the template, and it's not considered as much as biometric data, but it's something that it's also a difference between the nations. So I really can't answer fully there, but being on device should simplify that, and also being on template only and not biometric data as fingerprints should simplify. Yeah.
Okay, that's good. You mentioned even about the security of the presented solution today. How secure it is? I mean, because you mentioned even like credit cards. So I
Yeah.
believe that it should be very secure in this case.
So it's all, yes. So security is always a bit of a difficult thing to quantize, right? But I mean, we have passed all the payment schemes certifications for our biometric library, and also our anti-spoofing library. So I think that's on par with the top level of security needs that you need to pass, right? So the algorithm is very security resistant, I would say, at this point.
Okay. And the last question is from me actually. So I would like maybe if you have an idea of which markets are going to explode in the next years for
Oh,
fingerprints.
that's a tricky thing. So I will take my wizard box and explore. No, but I think what we're seeing is we're seeing digital access, logical access, or whatever how you mentioned that, is probably taking off with FIDO as one of the main drivers. So and that is then coupled to the passwordless part. So everything that has a digital service that you need to access to, if you can do that with just a touch of your fingerprint, that should simplify life for a lot of people. And I think that is also where we have a large volume forward. Or
Okay,
potentially,
thanks.
at least. Yeah.
Thanks. Glad to hear that. Okay, so no more question for you. So I think that we can close the webinar now. Thank you, Matthias. Thank you, Gonzalo. Thank you to all our customers, of course. See you next time. So for the next webinar.
Thank you.
Thank you. Have a nice day.